This code snippets mounts Google Drive in a Google Colab environment. It allows to access and manipulate files stored in Google Drive directly from our Google Colab notebook. After running it, you can use file path content drive to access our drive's contents. This code imports a library called pandas, which helps you work with data easily. Then it loads a file named Indira XLX from our Google Drive into a table called data frame. This allows you to view and analyze the data in the Excel file. Here you can see the df.head of 10. Df means data frame. Head of 10 is used to store the first 10 row values. Data frame dot shape means 90 rows and 2 columns. Here you can see the data frame information. Um, there are 90 rows of data from 0 to 89. There are 2 columns. This columns has a 10 dates and they are recognized as a date and time of date. In inverter 1, this column also has 90 values and they are numbers, floating point and values. Memory usage, the table uses about 1 kilobytes of memory. Overall, it shows that our data is complete and what types of data each column contains. In this code, the data slipped into 2 parts. Most of it for training the model is 96% and small part of the testing it 4%. In short, this code gets our data ready for machine learning model. In this, the LSTM layer, a type of layer good for working with sequence with the 50 units. The input shape is set of match the date you prepared earlier. This code sets up a neural network model for making prediction based on our data. Here you can see the training data and the testing data. Approaches means number of iteration. We are in this code we are doing 50 iterations. In this graph, you can see the 2 lines. The blue line indicates the training the data, and the orange line indicates the testing the data. In this graph, also you can see blue line is the actual data, and orange line is the predicted value. You can see the RMSE. RMSE means root mean square error. It is used as a perfect measure in continuous motion prediction, and in this RMS value, the number is less. Then we can predict. Then say that we can say that it is a perfect model. Finally, in this graph, the main aim of this model is to reduce the predicted generated power. Here in this, you can see the predicted values is less than the actual value, so that we can say that this is a perfect model.